In today's lesson, we shall be looking at exponential equation leading to a simultaneous equation. Questions on indices can be framed in such a way that at the end we'll be having a system of equations for you to solve. So here are some few examples that we are going to go through to see how best we can solve questions of this nature. So we have our first example. We want to find the value of x and y that satisfy these two equations. So we have the first equation and then the second equation. So let's call this equation equation 1, and let's call this equation 2 for identification sake. Now you can see that with the first equation, which is equation 1, we are having what? A linear equation. But with the second equation, which is equation 2, we are having what? An exponential equation. So you can do something about it. So we said that when you have 1 over a, we can write it as what? A raised to the power negative 1. That is the negative index property of indices. So it means that when you have 1 over 4, we can write it as what? 4 raised to the power negative 1. So in place of 1 over 4, we are going to write 4 raised to the power negative 1. So we have the second equation to be 2 . And now we want both bases or the bases on either side of the equal sign to be the same so that we can equate their exponents. So from here we can write 4 as what? 2 times 2. And we can write this as 2 raised to the power 2. So in place of 4, we are going to write 2 raised to the power 2. So we have 2. But remember, we have negative 1 here. Applying the power law, which says that when you have a raised to the power m or raised to the power n, you can write it as a raised to the power m multiplying what? N. So you can write this as 2 raised to the power negative 2. Now, once the bases are the same, we just have to equate their exponents. So we have x plus y, and that is equal to 2. So therefore, our equation 2 is now in this very form. So we have a linear equation and then a linear equation. So let's bring. So we have two systems of equations and we can solve them simultaneously. And in doing that, we can use various methods. We can use the elimination method, the substitution method, the graphical method. You can even use the Cramer's rule. The calculator is also there to assist you to find the value of x and y. So let's stick to one of them. Let's use the elimination method. So in doing that, we have to eliminate one of these variables in these two equations. Let's eliminate what? The variable x. So in doing that, then we have to multiply one of these equations by negative 1. So we have multiply, let's multiply equation 2 by what? Negative 1. So in doing that, this is our equation 2. When we multiply it by negative 1, we are going to have negative x minus negative y is equal to, this will give us positive 2. And this will become our equation 3. So we are going to add equation 3 and then equation 1 together. And then equation 3 we have. Now we are adding them together. So we have this plus this will give us 0. This will give us what? 5y. And this is also giving us what? 5. Now we are looking for the value of y. So let's divide both sides by 5. Both sides by 5. This will cancel this. This will cancel this. We have 1 over 1. And that gives us what? 1. Therefore, the value for y is equal to 1. Now that we have one of the values, we can substitute it into any of these equations, equation 2 or equation 1. So let's substitute it in equation 2. So we have substitute 2. So we have x plus y is equal to minus 2. we have our x plus our y is equal to 1 is equal to minus 2. We are looking for x, so we have our x is equal to minus 3. So the value for x that satisfy these two equations are x is equal to minus 3 and y is equal to positive 1. Let's look at our next example. So we have to find the value for x and y that satisfy these two equations. So realize that with the first equation, let's call it equation 1, and then let's call this equation 2. Now with equation 1, you realize that we are having an exponential equation. Equation 2, we are also having an exponential equation. So let's turn these two equations into a linear equation. So we know that 2 raised to the power x minus y, which is equal to 8. This is equation 1. Now we know that 2 times 2 times 2 will give us 8. And we can write this in an index form as what? 2 raised to the power 3. So in place of 8, we are going to write 2 raised to the power 3. And in place of 1, 2, 8, we are going to have 2 raised to the power 7. Because 2 raised to the power 7 will give us what? 128. So we shall have 2 raised to the power x minus y is equal to 2 raised to the power 3. Now once the bases are the same, we can equate their exponents. So we have x minus y is equal to what? 3. So this is our equation 1. Now let's look at equation 2. We can write this as 2 raised to the power 7. Once the bases are the same, we can equate their exponents. So we have 3x minus y is equal to 7. So this is equation 2. Now once we have a linear equation, which is this and that, we can solve them simultaneously using any of the methods. So we have our equation 1. Let's write it well. X minus y is equal to what? 3. So this is what? Equation 1. Now we can use any of the methods. Let's use what? The elimination method. So we are going to multiply any of these equations by negative 1. So let's choose equation 1. So we have multiply equation 1. So at the end, we have equation 1 to be minus x plus y is equal to minus x. Let's call this equation 3. Now we have equation 2 to be 3x minus y is equal to 7. So let's add equation 3 and equation 2. So we are adding them, this and that will give us what? 2x. This will give us 0. And this is going to give us what? 4. We divide both sides by 2. So we have our x is equal to 2. Now once we have one of the variables, we can substitute them into any of the equations. Let's substitute it into this equation 1 or equation 2. So we are substituting x is equal to 2 into equation, let's call equation 3 or equation 2. So we have 3, our x is what? Is 2 minus y is equal to 7. So we have 6 minus y is equal to what? 7. We are looking for what? Y. So we have our y is equal to 6 minus 7. Therefore, our y is equal to minus 1. So the value for x that satisfies these two equations are minus 1 and then 2. Let's look at one more example. So we have our last example. We want to find the value for x and y that satisfy these two equations. So we have equation 1 and then equation 2. So let's call this equation 1 and then this equation 2. Now with equation 2, applying the multiplication law, which says that when you have any two numbers multiplying, they have the same base. We pick one of the base, we add their exponents. So with this, it means that when you have 2 raised to the power x plus 2, we can apply the multiplication law of indices to write this as 2 raised to the power x multiplying 2 raised to the power 2. So in place of this, we can write what? That. So we have 2 raised to the power x multiplying 2 raised to the power 2. And then with this, we can apply the multiplication law as well and write it as 2 raised to the power y multiplying 3 raised to the power 1. When two numbers are multiplying, they have the same base. We pick one of the base, we add their exponent. So this is the same as that. So this is still our equation, what? 2. So we have 2 raised to the power to give us 4, 2 raised to the power x, and then we have 3 raised to the power y is equal to 8. So we have our equation 2. Now let's write our equation 1 beneath. Now this is also a simultaneous equation in disguise. So you have to unveil it. Now we can do that by letting any variable at all, let's say a be equal to 2 raised to the power x, and then b be equal to what? 3 raised to the power y. So wherever we see 2 raised to the power x, we are going to substitute it into these two equations. And wherever we see 3 raised to the power y, we are going to substitute b in place of that. So let's look at the first one. So we have 4. 2 raised to the power x, we are using what? A. So we have 4a, and then minus 3 raised to the power y, we are using what? B. And this is equal to 8. Equation what? 1. Now let's move on to this equation. So this is equation 2. Let's move on to equation 1. We are saying that 2 raised to the power s, we have to use what? A. So we have a, and then plus 3 raised to the power y, we are using what? B. And this is equal to 9. So we have equation 1. So with this, you can see clearly that we are having two systems of equations, and we can solve it simultaneously using the elimination method. Now I want to use the elimination method, so we have to eliminate one of the variables. So let's eliminate what? The variable b. And we can do that by multiplying equation 1 by 3, so that this and that will cancel. So we have to multiply. So we are going to have 3a plus 3b is equal to 27. And this is what? Let's call it equation 3. Let's add equation 2. Now we are going to add equation 3 and equation 2. So this and that will give us what? 7a. This and that will give us 0. And this and that will give us what? 35. We are looking for the value for a. We divide both sides by 7, both sides by 7. So we have our a is equal to what? 5. Now once we have one of the values for one of the variables, we can substitute it into any of the equations. So let's substitute it into equation 1, this one. So we have a is equal to 5. So we have 5 plus b is equal to what? 9. We have our b is equal to 4. So the value for a and b that satisfy these two equations are a is equal to 5 and then b is equal to 4. But I realize that in the equation we don't have a and b, but we have what? X and y. We introduce a variable a and b, so we have to bring back our x. So we said that our a is equal to what? 2 raised to the power x. And what is the value for a? Our a is equal to what? 5. And then we said that our b is also equal to 3 raised to the power y. What is the value for b here? Our b is equal to 4. Is equal to 3 raised to the power y. Let's continue from this side. So we have 5 is equal to 2 raised to the power x. You realize that the bases on either side of the equal sign can't be the same. So before we can solve this, then we have to introduce logarithm to the base of what? 10 on either side of the equal sign. So we have, now applying this property of logarithm, which says that when you have logarithm b to the base of a, can be expressed as this s will come in front. We have logarithm b to the base of what? A. So we are going to apply this property to express this as what? That. So we have x, this will come in front. We are left with log 2 to the base of what? 10. We are looking for the value of x. So let's divide both sides by log 2 to the base of 10, log 2 to the base of what? 10. So this and that will cancel. We have now when you punch it on your calculator, we have 2.321. Let's leave it to 3 decimal places. So the value for x is equal to 2.321. Now let's find the value for y. So we said that 4 is equal to 3 raised to the power y. Since the bases on either side of the equal sign can't be the same, we have to introduce logarithm to the base of 10 on either side of the equal sign. So we shall have applying the property of logarithm as we applied here, we shall have y log 3 to the base of 10. We are interested in the value for y, so let's divide both sides by log 3 to the base of 10. Then we have log 3 to the base of 10. So the whole of this will cancel this. We are left with, and this is equal to y. Now when you point this on your calculator, we have our y is equal to 1.262. So these are the two values that satisfy these two equations. This brings us to the end of today's lesson. I'm going to give you 1 to 2 set question. Try your hands on it. So this is your question. Bye bye.